molecular orbital energy level diagram. Today we'll discuss about atomic structure of energy level diagram, that is MOED of homonuclear diatomic molecule. So homonuclear diatomic molecule, the best example is here H2. H2. In the H2 molecule, each hydrogen atom have a 1 electron in 1s orbital. So totally in H2 molecule, the total number of electrons in H2 molecule is 2. 1 plus 1, 2 electrons. So here MOED, molecular orbital energy level diagram here. That is hydrogen atom in 1s have 1 electron and another hydrogen atom have 1s orbital have only 1 electron. So 1 plus 1, 2 electrons. So here sigma 1s 2 only, sigma star 1s 0. So here the number of electrons in bonding orbital is 2, number of electrons in anti-bonding orbital is 0 only. So here the one electron from one hydrogen atom and another electron from another hydrogen atom have the overlap to each other in formation of an bonding orbital and anti-bonding orbital. But the electrons will enter into the bonding orbital, there is no electrons in anti-bonding orbital. So number of atoms which you are going to be overlap, that number of molecular orbital will be left out from the formation. So here that bond order is equal to number of electrons in bonding orbital minus number of electrons in anti-bonding orbital. So simply here number of electrons in bonding orbital, number of electrons in anti-bonding orbital by 2 only. So when we discussed about that bond order here, the total electrons in bonding orbital is only sigma 1s 2 only. There is no electron in anti-bonding orbital because hydrogen have only 1 electron, another hydrogen have 1 electron. So totally we have 2 electrons. In the 2 electrons, first of all fill in bonding orbital, then we'll go to the anti-bonding orbital. So that bonding orbital have only 2 electrons, there is no electron in anti-bonding orbital. So 2 minus 0 by 2, that will be equal to 2 by 2, that will be equal to 1. So here that bond order is equal to 1, means here in between hydrogen and hydrogen have only one bond, that is a single bond, that is a sigma bond. So here the hydrogen have a 1s orbital have only one electron, so s is a spherical in shape, and another hydrogen has the same spherical in shape. The two spherical shapes are overlap to each other. In here the overlapping is occurring within the axis, and there is the formation of a sigma bond only. So here there is only one bond which is present in between the two hydrogen atoms. So here that one hydrogen have a one electron, another hydrogen have one electron, so totally 2 electrons. Then you write it as a bond order is 1 only. So in hydrogen, that is the 2 hydrogen in H2 molecule, in H2 molecule have only a single bond, that is a sigma bond. And when you come to the magnetic nature, that magnetic nature means a number of electrons which is present in bonding and anti-bonding orbital. There is no electron in anti-bonding orbital, but in bonding orbital the electrons are paired up. So the nature of the magnetic property for H2 molecule is diamagnetic, means dia means 2, so that electrons will be paired up in a bonding orbital. So the bonding orbital have electrons will be paired up, and that you call this as a diamagnetic in nature only. And next when you come to the F2 molecule here, that F2 molecule, that fluorine atom, one fluorine atom, the atomic number of fluorine atom is 9 only, 9. So 1s2, 2s2, 2p, 5. 1s లో 2 electron, 2s 2 electron, 2p లో 5 electron. So totally here we have a 5 plus 2, 9 electrons. One fluorine atom have a 9 electron, another fluorine atom also have a 9 electron. So total in F2 molecule 9 plus 9, that will be equal to 18 electrons here. That is a 18 electrons. So then you write it as a molecular orbital energy level diagram. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2pyz2, pi star 2pz2, and sigma star 2px 0 only. So then when you discussed about this molecular orbital energy level diagram here, in this molecular orbital energy level diagram for fluorine atom, 1s2, 2s2, 2p5. So first left side you write one fluorine atom, and another right side write another fluorine atom, that is 1s2, 2s2, 2p5, 1s2, 2s2, 2p5. So totally we have 9 plus 9, 18 electrons, and these 18 electrons will be filled in a bonding and antibonding orbital. First of all, when we enter into the innermost orbital, that is a 1s2, 1s2. So totally 2 plus 2, 4 orbital, and that 4 electrons. So 2 orbital have a 4 electrons, and that 4 electrons will be filled in bonding and antibonding orbital, that is a sigma 1s2, sigma star 1s2. So sigma 1s2, sigma star 2s2, that is 1s orbital. And next 2s orbital, when you come to the 2s orbital, so 2s have a 2 electron and 2s2 have a 2 electron. So totally we have a 2 plus 2, 4 electrons. In this 4 electrons, that 2 plus 2, 4 electrons, that electrons will be enter into the bonding orbital and antibonding orbital. So here 2 plus 2, 4. So here 4 electron, 2s 4 electron, and 1s also have 4 electron, 4 plus 4, 8 electron. And next we will go to the 2p orbital of one fluorine atom and 2p orbital of another fluorine atom. Each p orbital have 5 electrons. So as per Hund's rule, so that first of all empty orbital will be filled in single electron, then the electron will be paired up. So the whole 2 paired electron, 1 unpaired electron in one fluorine atom. Same in another fluorine atom also have a 2 paired electron and 1 unpaired electron. So totally here 5 plus 5, 10 electrons. Then these 10 electrons will be filled in bonding and antibonding orbital. So here the electrons is more than 14, then that the first electrons will be enter into the sigma 2px orbital, that is sigma 2px2. Then next enter into the pi 2py, pi 2pz, then the electrons will be paired up. So pi 2py2, pi 2pz2. So totally we have a 2 plus 2, 4, 4 plus 2, 6 electrons, and rest of we have a 4 more electrons. So in bonding orbital, sigma 2ps2, sigma 2px2, pi 2py2, pi 2pz2. And next the rest of 4 electrons first enter into the pi star 2py and pi star 2pz, then electron will be paired up pi star 2py2, pi star 2pz2. So totally we got here totally 10 electrons. There is no more electrons, so sigma star 2px 0. So here that filling of an electron, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py2, pi star 2pz2. There is no electron in sigma 2px 0 only. So here when we discussed about this electronic configuration, in next bond order, that bond order is number of electrons in bonding orbital minus number of electrons in anti-bonding orbital. So totally in bonding orbital, that is sigma 1s2, sigma 2s2, sigma 2px2, pi 2py2, pi 2pz2. So 6, 7, 8, 9, 10. So 1s2 lo 2, 2s2 lo 2, and sigma 2px2 and pi 2py2, pi 2pz2. So totally 10 electrons in bonding orbital. Next anti-bonding orbital, sigma star 1s2, sigma star 2s2, pi star 2py2, pi star 2pz2. So totally we have 8 electrons. Next 10 minus 8, when you do here, we will be resting off 2 by 2, that will be equal to 1. So in between fluorine atom, fluorine molecule, in F2 molecule, the fluorine have a only single bond, the presence of a one sigma bond. So here all electrons are paired up in all bonding and anti-bonding orbital. The magnetic nature of fluorine atom is diamagnetic in nature. Here bond order for F2 molecule is 1 only, and the electrons how will be filled in MOED for F2 molecule, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py2, pi star 2pz2, sigma star 2px 0. So here the filling of MOED in F2 molecule is like that. In bond order is 10 minus 8 by 2, that will be equal to 1 only. In FF, in between FF only single bond, sigma bond is present. And next magnetic nature, how it is present as a magnetic nature, that is a diamagnetic in nature only. Next, next molecule, next homonuclear diatomic molecule is O2, oxygen. Oxygen atomic number is 8 only. So here oxygen is 8, 1s2, 2s2, 2p4. And here another oxygen also have a 1s2, 2s2, 2p4. 4 plus 2, 6, 6 plus 2, 8. 8 plus 8, 16 electrons in O2 molecule. So molecular orbital electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py1, pi star 2pz1, and sigma star 2px0 only. Next, MOED of filling of an overlapping of an oxygen and oxygen atom. First one s have a 2 electron, another oxygen has a 2 electron, totally 4 electron. That 4 electron will be filled in sigma 1s2, sigma star 1s2. And next 2s2 in a 2s2, here 2 electrons is there in a 2s orbital, that is also filled as a bonding and anti-bonding orbital, that is sigma 2s2, sigma star 2s2. And in p orbital, the oxygen have a 4 electron, another oxygen has atom have a 4 electron, 4 plus 4, 8 electron. In that 8 electron will be filled first bonding orbital, that is in a sigma 2px2, and next pi 2py, pi 2pz, that is a 2 plus 2, 4, 4 plus 2, 8. And we have a rest of 2 electrons, and the 2 electrons will be enter into the pi star 2py1 and pi star 2pz1. So in antibonding orbital of p is only 2 electron, the 2 are unpaired. And in bonding orbital, that is all are paired, that is sigma 2px2, pi 2py2, pi 2pz2 only. So next, when you come to the bond order, the bond order of O2 molecule, number of electrons in bonding orbital minus number of electrons in antibonding orbital, that is 10 minus 6, that is 1s2, 2s2, sigma 2px2, pi 2py2, pi 2pz2. So 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10. So next, in antibonding orbital, number of electrons in antibonding orbital, sigma star 1s2, sigma star 2s2, pi star 2py1, pi star 2pz1. So 1 plus 1, 2, 2 plus 2, 4, 4 plus 2, 6 only. So 10 minus 6, that will be equal to 4. So that 2 cancel, that will be equal to 2 only. So oxygen, in between the oxygen, there is a presence of a double bond, one sigma bond and one pi bond only. So here the magnetic nature, of O2 molecule, that is as a paramagnetic in nature. Why paramagnetic in nature? The presence of in antibonding orbital have a unpaired electron, that is a pi star 2py1, pi star 2pz1. That's why O2 molecule, the magnetic nature is paramagnetic in nature. That is a pi star 2py to pi star 2pz, that contains an only single electron. So presence of that single electrons, the magnetic nature of O2 molecule is paramagnetic in nature, whereas bond order of O2 molecule is 2. It means in between oxygen have presence of double bond only, one sigma bond and another as a pi bond only. So here this is as a O2 molecule. Next, N2 molecule. In N2 molecule, that is the nitrogen atom have an atomic number is 7. 1s2, 2s2, 2p3. So total number of electrons is 14. 3 plus 2, 5, 5 plus 2, 7. 7 plus 7, 14. In N2 molecule, total electron is 14. So molecular orbital electronic configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2py2, pi 2pz2, sigma 2px2, and pi star 2py0 and pi star 2pz0, and sigma star 2px0 only. So here that is the 1s2, 2s2, 2p3. One nitrogen atom. Another nitrogen atom also have 1s2, 2s2, 2p3. First inner orbital will be overlap between the two nitrogen atom, that is sigma 1s2, sigma star 1s2. So 1s2 have 2 electron, and the nitrogen have 1s2, 2 electron. So 2 plus 2, 4 electron, that is bonding and anti-bonding, that is sigma 1s2, sigma star 1s2. And next 2s2, 2s2. So 2 plus 2, 4 electron, sigma 2s2, sigma star 2s2 only. And in p orbital have a 3 electron, and in p orbital have a 3 electron, that is a 3 plus 3, 6 electron. So pi 2py2, pi 2pz2, sigma 2px2 only. So 3 plus 3 6 electrons. Here the presence of total electron is 14. That's why the electron first enter into the py/pz orbital, then goes to the px orbital. So here the pi 2py2, pi 2pz2, then a sigma 2px2. There is no electron in pi star 2py0, pi star 2pz0, sigma star 2px0. Here the bond order of N2 molecule, that is a bond number of electrons in bonding orbital minus number of electrons in anti-bonding orbital by 2 only. So here number of electrons in bonding orbital sigma 1s2, sigma 2s2, sigma 2 pi 2py2, pi 2pz2, sigma 2px2. Here totally 10 electrons. In an anti-bonding orbital sigma star 1s2, sigma star 2s2. 2 plus 2 4 electrons. So 10 minus 4, that will be equal to 6. 6 by 2 is equal to 3 only. So in between nitrogen atom have a triple bond, 1 sigma bond and 2 pi bond. 1 sigma bond and 2 pi bond. So the magnetic nature is all electrons in a MOED, that is a molecular orbital, that is a bonding and anti-bonding orbital, all are paired only. So here all are paired, then the magnetic nature of this N2 molecule is diamagnetic in nature. And next O2 minus ion. In O2 minus ion, the oxygen have a 16 electron. O2 minus means there is a minus charge, is the gaining of one more electron, it becomes as a O2 minus. So 16 plus 1, 17 electron. So one electron is added in the antibonding orbital of oxygen, then O2 minus is formed. So here electronic configuration of O2 minus is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, sigma star 2py2 and pi star 2pz1. So here, and that the electrons which is entering into the here, that is the pi star 2pz1 only. So here the electron which is filled in this order, that is 6 plus 1 17. So in oxygen have only 8 plus 8 16, but one more electron which is present actually in O2 molecule, pi star 2py1, pi star 2pz1. But there is a gaining of one more electron, then the electron will be paired up at pi star 2py2 only. So number of electrons in bonding orbital minus number of electrons in anti-bonding orbital, that is a 10 minus 7, that is the 3 by 2, that will be equal to 1.5. So here the one is a sigma bond and a half, that is a 0.5, that is 50% ionic and 50% covalent in nature. And there is a one electron which is present as a unpaired in pi star 2pz1. So here O2 minus ion, the magnetic nature is a paramagnetic in nature only. So here next O2 minus ion, in that O2 minus ion, here the 2 electrons will be gained up. So total in O2 total electrons in O2 molecule is 16, but O2 2 minus means that is a 16 plus 2, that is a 18 electrons. So the 2 electrons are added into the antibonding orbital, that is a pi star 2py, pi star 2pz of oxygen O2. Then the O2 minus is added. The electronic configuration of O2 2 minus ion, sigma 1s, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, pi star 2py2, pi star 2pz2, sigma star 2px0. So here sigma star 2px0 here means that oxygen have a pi star 2py1, pi star 2pz1, but in O2 minus ion have pi star 2py2 only. But when you take O2 2 minus ion, that is a pi star 2py2 and pi star 2pz0 only. So number of electrons in bonding orbital minus number of electrons in anti-bonding orbital, that is a 10 minus 8 by 2 only, that is a sigma 1s2, sigma 2s2, sigma 2px2, pi 2py2, pi 2pz2. Up to here 2 plus 2 4, 4 plus 2 6, 6 plus 2 8, 8 plus 2 10 only bonding orbital. Whereas in anti-bonding orbital, sigma star 1s2, sigma star 2s2, pi star 2py2, pi star 2pz2. So 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. So 10 minus 8, 2 by 2, that will be equal to 1. So in between oxygen, that is a charges, that is a O2 2 minus ion, that presence of a single bond, that is the presence of maybe as in the sigma bond only. So all electrons which is present here in this O2 2 minus ion are maybe as a diamagnetic in nature. So O2 minus ion, that is that gaining of the 2 electron. So the 2 electron will be enter into the oxygen of antibonding orbital, that is a pi star 2py2 and pi star 2p z2 only. So by entering of the 2 more electron in antibonding orbitals, all electrons are paired up. So here the magnetic nature is a diamagnetic in nature. Whereas when we discussed about this bond order, that bond order is 2 by 2 is equal to 1 only. So there is a presence of a single bond between the O2 2 minus ion.